Hi, in this video, we're going to be revisiting the example from chapter 17 on topic modeling. So what's different in revisiting an example versus the extensions that we've posted videos about for some of the other chapters? Well, the extensions are cases in which we wanted to show you ways where you could do more. So take the example we provide in the chapter and add additional analysis to get more insights. Or in some cases, show you different analytics techniques that can help you arrive at the same set of insights that the example we provide in the chapter. Here, when we revisit an example, what we're going to do is we're going to actually just use the same data and the same code that we used in the example, in this case, text analysis from chapter 17, and show you how we might get new results. Not necessarily different insights, but new results. So why is that the case? Well, for machine learning techniques, such as unstructured data analysis that we're doing here, there have been evolutions in the way that machine learning has changed how we process text, as well as how the algorithms themselves build associations with that processed text. And this is very different than, let's say, our other chapter examples, where we might have, let's say, a regression that we're running. Now, regressions haven't changed since they were introduced. So if you use the same data and the same variables that you put in your model, and you run the same code on that data, you'll get the same result. You'll get the same coefficients and model fits and so on. In machine learning techniques, as we continue to train the machines to do a better job of processing data and analyzing that processed data, we'll see some evolution in the results we get. Now, the hope is that as we improve on these processing techniques and we improve on the way we analyze this processed data, that we'll get better and more refined results that will have stronger associations, maybe reductions in noise, words in this case that might be irrelevant but are showing up because the algorithm doesn't know what to do with them. So what's an example of what might happen? Well, when text analysis was first introduced, there were very simple methods for doing the analysis. Let's say a bag of words approach, in which the algorithm might just look for the number of times it sees the same word show up in a different document. Well, what we've learned is that different words might be similar to each other, even if they're not spelled the same. Now, there are synonyms where you have completely different words that might have similar meanings, but you might also have words such as the singular and the plural version of a word that are really capturing the essence of the same topic, but aren't exact matches with each other. That's where we trained machine learning models to stem words, or essentially chop off the end of a word so the root word could be compared more similarly, and we could do a better job of finding some of those associations. We've continued to see improvements in these methods of word processing and text processing, which have dealt with things such as contractions, where, as an example, will not and won't are essentially the same thing, but might be seen as very different. And by just stemming the words, we're not going to get similarity. So what we're going to look at here in this revisited example is what's happened since the release of the book, in this example of chapter 17, about a year ago, to today, in terms of how do the results change? How does the text processing see some differences? And how does the topic modeling see some differences in the way that some of these methods have evolved? So what I'm going to take some time to show you is we're going to run the new analysis, or essentially the same analysis with the new methods, same code, same data, and so on. And then we'll compare and contrast between what we have in the book as the example, which at the time that the book was published, what the results were, versus the results that we get now, and then reflect on whether that has any new insights or meaning, and what we can really learn from this evolving area of machine learning. So let's start by just looking at the basic code. So as I mentioned before, the code didn't really change. I loaded up the same code that we provide with the book, and the code is in the linked in the description of this video. But it's the same code as we had before in chapter 17, where we're analyzing this product review data about Apple Watches. So what we're going to do is we're going to run the same analysis as we did in the original chapter 17 example. And if you have not watched the chapter 17 video where we walk through that, I encourage you to do so. I'll also link the video of the original chapter 17 walkthrough in the description below. But let's go ahead and run this. So I've already installed the new packages. So essentially they're the same packages, but we just install them again to overwrite the original packages with the new machine learning algorithms. So I'm going to go ahead and load those packages up, just like we've done for all of the other examples. Okay. So let's go ahead. The next step is we're going to load up the data, and that's that reviews data file that's provided with the chapter example. So we can see it'll be the same as before. It'll look the same as the example we had in the chapter 17 example, where we show there's titles to the review, there's the text to the review, there's the stars to the review that we'll all use in this analysis. Now, I am not running this on a Mac OS-based computer, so I do not need to run this line. If you're running it on a Mac, first, you'll need to run this line to encode the text correctly. Second, you will also notice that because of different text encodings, there might be variations in the results you get if you run on a Mac versus what you run on a PC. So the results you'll see here are the results from running on a PC. So the first thing that we're going to do is we're going to process the documents in the same way as we did before. We're going to remove the stop words, the custom stop words that we've added here, and so on, and see what happens. So we'll go ahead and run this, and it will tell us what it's done in terms of processing the documents. Okay, so we'll see here that it finds that some of the documents, after it removes some of the stop words and other things, the documents had 0 text in them, so those got removed. But you ended up with 2,192 terms, which means vocabulary terms, so different words. And you'll see those words 52,413 times. So those are the tokens. Those are the different words across all the documents. So the 2,192 words across all the documents. The next thing we want to do, now that we've processed this, is we're going to go ahead and run the topic model and print out how many topics we get. Same code as before. We'll go ahead and get this started. And as this begins to run, what I'm going to quickly do is we're going to jump away from this, and we're going to look at sort of the difference in the text processing to see what's changed between running it today and when we originally ran the analysis about a year ago. So let's go ahead and take a look at that. So in the last year, when we process the text, we see some small differences, not a lot, right? So in the last year, there hasn't been a significant amount of change in how the text is getting processed. So we ended up losing 2 additional documents that we had in the previous round. Now, this might be due to the fact that the program was able to identify, or the processing was able to identify additional, let's say, stop words, words that are common uses of language, maybe emojis, maybe contractions, maybe other things that were noise in the data before. And as a result, we ended up with 2 fewer documents. It actually came from having 1 fewer vocabulary term, right? So in the previous example and in the original text, we saw 2,193 terms. We're now down to 2,192 different vocabulary terms, in which we see across these 4959 documents, we see these 2,192 terms showing up 52,413 different times, right? Which is only 10 times less, 10 tokens less than we saw in the previous. So in terms of processing of vocabulary terms, we don't have a big difference in what's happened in the past year in these different stop words and other things. So now what we're going to do is we're running the analysis. I'm going to jump ahead to the analysis being finished, and we're going to see what happens. So let's go back to the finished analysis now. So we can see everything finished. Our algorithm finally converged, and we ended up with 48 different topics, right? So we see it took 149 iterations to go through and be happy with the result. We ended up with 48 topics. Now, going back to this comparison that we just were looking at, what do we see as similar and different? Well, if we look at the iterations and the topics, we see significant changes in terms of number of iterations. So we see our original analyses about a year ago had 196 iterations, and this analysis today is 149. Well, what this means is that the algorithm was able to more quickly resolve what it thought was a good fit between the words into the topics across the documents. So hopefully this is due to the fact that it's found better and stronger relationships between the words, and also perhaps ways to reduce the noise that's resulting from words that might be unassociated with other things. The end result of this is the original analyses, we had 57 different topics, and now we're down to 48 different topics. So it has further refined our set of topics into hopefully 48 stronger, at least stronger in their word association topics that can help us continue to draw those insights. So let's see if that's true. Let's see if these topics that we're getting look similar or very different to the topics we got back about a year ago. So let's go back to the analysis. So now down here, we're going to go ahead and run the part of the analysis that associates the topics with the star ratings, where it's going to tell us which topics tend to show up when the star ratings are higher, and which topics tend to show up when the star ratings are lower. So in this case, it's going to associate the topics with star ratings, and anything that shows up on the right-hand side. So let's see here, let's expand this out so we can see it better. So anything that's showing up over here are examples of topics that tend to show up when people gave higher star ratings. And the things showing up over here are examples of topics where they show up when people give lower ratings. So if we identify a few topics, so in our example in the textbook, we identified the top 3 and the bottom 3 topics. So here we might certainly identify topic 27 as being very positive. Topic 20 looks pretty positive. 25 also, you could argue maybe 38 too, and so on. So all of these topics that are on this side are positive. So if we look at the top 3, we'll look at 27, maybe 20, and 25. We can do the same thing for the negative topics. Certainly 4 is a very negative topic. 37 is a very negative topic, and 11 is a very negative topic. So now what we can do is we can create those word clouds, which will help us sort of visualize what these topics really mean. Let's go ahead and put this over here so it's easier to see. So let's look at those topics. So our positive topics seem to be topic 27 here, topic 20, and topic 25. And these topic numbers might change every time you run the analysis because it's randomly assigning topic numbers to these topics. But let's see what happens. Okay, so topic 27 is about how much somebody loves the Apple Watch that they have. right? It's perfect, it's good for work, and so on. Topic 20 is about all the features and attributes. So it can act as a phone, text, notifications, call, message, and so on. And topic 25, it's great. So it's just a superlative about the Apple Watch, and that it's great. I see the little word flawless here. Expect, maybe something will do with expectations and that you were satisfied and so on. Now, what about the topics that were negative? So if we go back to that plot, we can again look at topics 4, 37, and 11. 4, 37, and 11. So topic 4. Oh, okay. Topic 4 is that the screen doesn't work. I see crack, charger, stop within a month. So maybe within a month, they're getting a screen crack and so on. Let's see, topic 37 is pairing. So maybe there's struggle with pairing the watch to a device, maybe the phone, or if it's not an Apple phone, it might be even harder. Getting good support for that. And topic 11 here, Amazon, store, repair, defect, replace. So because these were product reviews that were on Amazon, these seem to be about issues with dealing with customer service related to Amazon. So let's see how these topics, positive and negative, compare with those that we had previously. And remember, these numbers will vary. When you run the analysis, you might get different numbers, but you should generally see the same word clouds that we're seeing here if you run the analysis in this version of the topic modeling. So let's jump back over to our comparison and see what we see. So from the original text about a year ago, we saw things like love, and we saw some family members here, absolute, but then also daughter and so on. We saw great price, so on. We saw the attributes. We saw it can answer, phone, call, message, notification, and so on. What do we see below? Well, we see that the topics seem to associate. We had one topic in the new version that was about love. We had a topic in the new version that was about great. So great is showing up here. And we have a topic in the new version that was all about the attributes. It can call, message, text, features, notifications, so on. So it seems to be the case that even though the analysis has reduced the number of topics that we have, it has come up with very similar insights in terms of the topics that it is generating, right? People seem to really like the fact that this watch can do a lot of different things, and they find it to be great and they love it. Right? What about the negative side of things? Well, in the original version of the text, we saw issues with replace, crack, screen, and so on. Amazon was showing up, so return, support, and so on. And here we see charger showing up, right? Adapter, charger didn't work, and so on. What did we see in the new version of these negative topics? Well, we see here that there was this issue with disappointment around screen. So screen seems to be connected here. Again, we saw Amazon showing up. So there seemed to be a topic that had to do with Amazon being difficult in terms of issues around resolving repairs or defects and warranties. But here we see slightly different, right? We see that this one is all about charger and previous device and adapter and didn't work. And this one is more about issues relating to updates and pairing and time. Now, remember, this is the same exact data. This is the same exact set of reviews that we were doing before. yet we see a slightly different topic showing up relative to this topic. Now, as we saw when we ran the analysis, that in fact, I believe we did see that charger did show up in one of these other topics. Now here, we're seeing sort of a new topic emerge of something, again, related to issues having with the watch, pairing and time and phone and work and that, but slightly different than the topic we saw before. So what have we really learned through this updated version, this revisited version of this topic model analysis? Well, what we've learned is that as machine learning methods continue to develop and evolve, we're going to see slight variations in the results that we get when we run the analysis. So it means two things. It means, one, we should continue to run these analyses to sort of update our insights. Hopefully, these methods are becoming better at creating these associations between these words and are coming up with more refined topics that are helpful to us as we think about the impacts of, in this case, product reviews on marketing decisions we might make if we were, say, the product manager for Apple Watch. We also, as we have talked about with other methods in this book, it's useful to continue to gather updated and new data and run these analyses to see how the world is evolving in the way consumers are processing information and responding to things and so on. So hopefully you saw in this revisited example that when we're dealing with these new techniques that are emerging and evolving in the field of marketing analytics, that there can be insights that evolve with those and analyses that provide us new and updated results that can help us draw those insights.